Welcome. I'm Hans Sendt. I'm a technical project manager in Danelec. And I'm going to tell you a little bit about the journey of Danelec to build our product or solution, which is called Danelec Edge. I don't know if you saw the keynote of Basil, where I had a small section of that one, but it's basically the same use case where I'm going to go a little bit deeper, a little bit broader, give you a lot more of the technical details, what's inside the box, so to speak. That's also reflected in the agenda. Again, I'd like to just briefly, I won't bother you that long with it, but just briefly touch in on what are the challenges that the maritime shipping industry is facing. A little bit on Danelec, where do we come from as a company, what are our key competences, etc. But then I would like to spend the majority of the time on our platform as a service solution, walking you through how we deployed the SUSE Edge stack, and I have a number of touch points that I would like to discuss and elaborate a little bit about our design choices around that. And then last but not least, I would also like to take you a little bit through our journey and especially our good experiences and our not so good experiences with SUSE and the SUSE ecosystem. So let's get started. Maritime shipping. Looking from the top, right now the maritime shipping industry is facing a number of challenges because historically it has been a very conservative, a very slow-moving industry. Basically, a captain he gets an assignment, pick up cargo at this port, deliver it at this port at this date. That's basically the assignment. Now, the industry as a whole is being faced by the green agenda, first and foremost. That means that there are a number of governmental bodies that are enforcing restrictions on allowed CO2 emissions. And at the same time, they are also enforcing requirements on reporting. How much fuel did you actually burn on this voyage, and what was the rate of your fuel burn, etc. Some zones of the oceans are actually low emission zones, you could call it, like you have in the cities. Some cities have their zones where you're not allowed to drive your diesel van into the middle of the center. Likewise, there are zones of the oceans that have not that tight regulations right now, but it's growing. The other thing mentioned up there, that's actually the access to money. More and more banks are putting up requirements that, okay, you need to include some kind of green agenda into your project if we are going to invest money into it. And in the shipping industry, there's something called the Poseidon principles. I don't want to go into those, but it's basically a set of principles whereby you basically enforce and enhance the green footprint or lower the CO2 footprint of the shipping industry. But actually, I think the largest player in this, that's actually the consumers, because many of the larger chains for consumables, that's being IKEA, Walmart, whatever, they are by now requesting certificates from the shipping company about how much fuel did you burn in order to move my packages, my cargo from A to B. And all of this calls for, of course, a more green way, let's call it that, of operating your fleet of vessels, but it also calls for extensive reporting and kind of proving what have you done during your voyage. Okay. Technically, the maritime industry is also facing, I don't want to call it challenges, but I want to call it changes. The the technical landscape for the shipping industry is rapidly changing these years. First and foremost, I think I've already kind of talked a little bit about that. That's high-frequency data. Up until now, or up until recently, the norm has been to report once a day at noon, report back to headquarters, what's my position, what's the level in my fuel tanks, and that's about it. A little bit cartoonish, but that's basically it. That's now moving into a world or a reality where there is basically being monitored and censored all around the vessel, all around the engineering room, but also on the cargo. For example, containers that are being with coolers in them are continuously being monitored about the state of the cargo, the temperature of the cargo, etc. And on the bridge, everything is being monitored, honestly speaking, and that being your heading, your speed, the weather around you, the sea state around you, all of that. And that's all being reported back to shore, back to cloud, and that's one of the areas where Danelec traditionally have been in the collection of data and shipping it to shore. But there's a player coming in there that's really radically changing the game, and that's around connectivity. Starlink, Elon Musk, that is really changing the landscape around connectivity to those vessels right now. Up until last year, the norm was a 1 megabit connection to a deep sea vessel. And you don't get a lot of stuff through such a thin pipe, especially if you are not alone on that thin pipe. That's one part of it. The other part of it is that it is highly unreliable. It comes and goes depending upon weather condition, depending upon if you are close to another ship where you may have interference from a radar or whatever. Starlink is changing that landscape dramatically because they are hitting a totally different price point as well as bandwidth point. So we have seen in the past year that ship owners are basically just installing Starlink on all their vessels, and if they can, they are installing 2. But at the same time, the geopolitical movements also frightens people a little bit. They don't want to put all their eggs into the hands of Starlink. So when we as a service provider is being faced by a requirement that, hey, you should be able to utilize all of that bandwidth for something useful, but at the same time, your system must be fully operational in the event that Starlink is not available, where you are falling back to the good old VSAT connection. Okay, fair enough. We can handle, but it's just a challenge. Last but not least, shared reality. Up here, I talked about high-frequency data and how we can move that to shore and perform all kind of data analytics on that data. And that has been kind of the historical or traditional way of working, that collect a lot of data from a ship, transmit it to shore, then you have some data analytics and superintendents that are sitting on shore, analyzing the data and giving advice back to the captain and back to the first officer. But that puts the captain and the first officer in a position where they don't really take responsibility of their own vessel. Because, I've been instructed to sail in that direction. Yes, it was head into a thunderstorm, but that was what I was told. And that's simply just stupid. Flat out stupid. So we see more and more companies that are asking for a shared reality where the vessel and the key personnel on the vessel have access essentially to the same data and to the same analytics as they have onshore in the cloud. But we should have it locally without any connectivity, essentially. Danelec, where do we come from? I think if you look up Danelec if you Google Danelec, then I bet that one of those orange boxes will come up, because that's really our roots. And that orange box, that's actually what I would call a black box. If you take the aeroplanes, they have black boxes that are recording everything that happens in the cockpit. When you are at a vessel that is above 3,000 tons, you need to have a voyage data recorder on the vessel. That one records everything that's happening on the bridge and stores for a period of time. That's kind of the outset, the historical starting point of Danelec. But that has been moving or been extended across the last, especially 5 years. We have included Kyma, who are building shaft power meters. I think it's a little bit difficult to see, but for those who like hardware, this is a ring that you put around the shaft that goes to the propeller, and that ring measures the torque and the compression of the shaft. And that tells you something about how much thrust are you actually putting backwards, and how much are your engine fighting to get your propeller to rotate. How hard are you pushing the pedal, so to say. And then last but not least, we have also included a company, Nautilus Labs, which performs, or which is a software-only company, but they have a suite of tools for voyage optimization and for ship performance optimization. So today we are a group that basically have two legs: safety and ship performance. And I don't want to brag, but we are recognized in the respective legs as being some of the best in the industry, because we build super reliable hardware, and we have a fine mesh of service technicians that can go on board vessels. So that's where we come from. And this doesn't really smell that much of Kubernetes, right? So right now we are helping vessel owners to move their digital readiness, as we call it, further up this S-curve. Right now we are focused around fuel efficiency and compliance, as I told you, and also in the optimization of the entire fleet and on the individual voyages. So that's kind of the backdrop for this use case, because March last year, one of the larger Danish shipping companies approached us because they knew us. We have shaft power meters and VDRs on some of their fleet, and their ask was basically, we would like to execute our in-house developed performance optimization and tracking applications. We would like to execute them on something, on a platform that you provide and service turnkey on our vessels. That was kind of, in a nutshell, the ask from them. And they consider their optimization software, they consider it not mission critical, but they consider it high operational value. And what I mean by that is that they state that they observe savings in the order of 4-digit dollars per month per vessel, where they are running their optimization software. So, and that's just by optimizing the voyage and optimizing the maintenance of the vessel. And then on top, they also have a number of reporting things, etc., but that doesn't really kind of reduce the OPEX. So what we did a technology scan and a rudimentary solution design. As I said, basically at this point in time last year, we were watching some of the presentations online from SUSECon 23 and saw the SUSE Edge product or the SUSE Edge software stack as something that really ticked many boxes in what we wanted, or the requirement base that we were looking into. So across summer, we built a proof of concept, basically a full system, but not with the full and correct configuration, etc. But built a full system, shared that with customer, and asked for their feedback. And they were actually that just kind of hit the sweet spot for them, because they were also on a cloud-native journey, I would call it. They were actually looking for a way that the applications that they develop in cloud should be easily transferable to the hardware on the vessels. Okay, good. It sounds like we have hit something here, because this is a fully containerized environment that we are providing to you. So full steam ahead. We did our homework, got the hardware assembled, and also the software stack fully configured and customized and integrated with their software pipelines. And that actually meant that we actually got ahead of our customer. Meaning that in early November, we said, now we are ready to ship out the first appliances. And then we got, nope, you are not allowed to do that, because we are not fully done with the software validation from our end. So we had a 3-week, I don't want to call it blackout period, but because of course we continued our work. But we were actually forced to sit a little bit on our hands with respect to physical deployment, because they were a little bit behind on their software. But end of the day, by late November, we got the first systems shipped out, installed on vessels, and started getting them into operation. The majority came into operation during January and February, and now we are basically continuing the rollout. So today we have delivered 40 systems in total out of our factory, I would call it, and of those 25 are fully in production. What is it that we have delivered? I think it's fair to say that there are 3 major components in our solution. First of all, there is an onboard appliance. That's basically a rack enclosure with 3 servers in it. It's a single box. It needs power, and it needs a network, and that's it. And that enables the crew to install it locally. We don't need a technician to go on board, and that was actually one of the key parameters also in this, that if we could develop a solution that could be installed by the crew, that would be a major advantage, because having a technician on board is a logistic and economic nightmare. I have never been at any of these vessels, because you need to go through a significant amount of certification and approvals in order to get on board, and then they are typically only in harbor for 6 to 12 hours, pulling off containers, adding new containers, off you go. So anything we could do where we basically should just ship a package onto the vessel, that would be fantastic. That appliance includes a full Kubernetes in a private cloud, and it's fully managed from shore. It's a triple server solution, such that when the satellite communication is absent and the cluster has or at least the servers have a malfunction, it can still operate. It can run autonomously, you could call it. The other major leg, that's basically the management side of it. We spin up a dedicated tenant for each customer we have on this solution. In that tenant, of course, Rancher lives there, but also a number of other components. So I'll get more into details about those later on. Especially for observability, etc., lives up there. But also a key thing here is that we connect directly to the CI/CD pipelines of the customer. So the customer we don't have any say or any action in deployment of their applications. We deploy the platform, they deploy the applications on top, directly to the vessels. We don't carry anything. We provide the piping, but we don't have any interaction as such. Last but not least, we have a full VPN network that basically builds a brick wall, I would call it, around the cluster on the ship, the tenant in the cloud, and spans the entire fleet. Meaning that you can go into the cloud and then you can basically jump host to any of the vessels out there. And especially, we are not interacting with the vessel network on anything but a single interface. That's a little bit important because traditionally the network on the vessels have been a mess. I'm sorry to say, and it's not to point fingers, but it has just been a handful of switches, a handful of routers, and somebody setting them up. It has been a mess, and no two ships are the same. So therefore, we decided to have our appliance as a single, fully segregated, fully isolated entity with a firewall sitting on top, and everything passes through that firewall. And we are in total control of that firewall. Yep.
Is this VPN provided by SUSE?
No, it's not. Here, let's start at the bottom here, because we have a Cisco Meraki sitting on top in the top up there, doing all of our routing and all of our firewalling. And it's actually on purpose that we have selected a hardware solution for that, simply in order to have total hands-off, I would call it, no interaction with the software or with any OS exploits. And then Cisco Meraki, I don't know if you're familiar with that one, probably not, but it's a fully managed solution. You cannot do anything on the physical device. It connects to a Cisco Meraki cloud, and all management is performed from that one. And that's also important for us because we experience all kind of tampering and trying to interfere with equipment that is on board. So once we have configured it, once we have control of it, nobody can interact with it. Yes, I think I actually covered a number of these elements. Right now, we have a 9U 19-inch rack as our solution. It's a big thing, physically and weight wise, and already by now we can see that we can build similar specs, but in basically half the physical size. But at the point in time where we designed this, our primary goal was actually to get something out to the vessels quickly, to get some quick learning, and very well aware that, okay, we may need to iterate our hardware bill of material at a later point in time. Yes, as I said, basically there are 4 elements in that rack. It's the firewall, 3 pizza servers, and a UPS from Eaton. That's basically it. Our cloud Just briefly, I touched on it earlier. As I said, it holds Rancher, of course, and we are utilizing Microsoft Azure, and that enables us to perform single sign-on and have a super simple or easy maintainable security concept around that, because the Azure Entra ID can be directly, we can invite guests from foreign entities into that one. So of course, we have a number of admins on the cloud, but then we also invite a number of guests, key personnel from the customer. In that way, we have a total shared reality between the two software departments. They can modify more or less as much as we can. Of course, we are responsible as Danelec, we're responsible for the platform and for Rancher, but they have almost equal access to Rancher in order to maintain and monitor the health of their applications if they like to. Okay, this is almost redundant. As I said, our SUSE Edge stack up. That's basically Rancher and the Elemental operator on that one. And on the vessel, we have Elemental Teal as the base OS, RKE2 on top of that one. But actually, I want to just jump a little bit ahead and go into these slides, because this is a number of touch points down on the design decisions that we made along this journey. First of all, we chose to run RKE2, and that was from a design concept, better safe than sorry, honestly speaking. We had the hardware available with sufficient power and memory to run RKE2, so we basically just said we rather have the full Monty than being sorry somewhere down the line. Now, with the knowledge we have today, K3S would be sufficient. I'm not in doubt about that. And when we enroll the next customer on this solution, we will most likely convert that customer to K3S. Then we have Terraform utilized for cluster configuration. A lot of people like Terraform, so do we. But at the same time, honestly speaking, we also hate it a little bit, because we definitely like the declaratory approach on Terraform, and the reason we selected Terraform initially was because it allows you fine-grained control about what is being pushed to a single vessel. So we really had our hands and feet totally we were totally in control about what is being pushed. Right now, honestly speaking, we are seeing the flip side of that, because we are now facing situations where we have 25 systems in operation with varying degree of connectivity. Some are totally off, others have good connectivity. We cannot do a Terraform apply across the entire fleet. We need to monitor the connection conditions to each and every vessel and then go and perform Terraform apply. So I think Terraform has done a very good job for us, no doubt about that. Moving forward, we are considering, we have not made a choice yet, but we are considering moving to a pull architecture instead, a more GitOps oriented architecture for that. Secret handling, there we utilize sealed secrets on the local clusters, and we have Key Vault in Azure. That's honestly speaking, that's a fantastic concept, seen from my point of view at least, and it was something that we agreed upon with our customer, or they came and proposed it, and we evaluated it. It allows us to do the majority of the secret handling on for behind, I would say. Put it up in Azure Key Vault, and then the cluster pulls the secrets itself from Azure Key Vault onto the individual clusters, and our customer can also interact with this Azure Key Vault. So we don't ship any secrets between us and our customer. They handle that themselves. Monitoring, I don't think no surprise. We use Grafana in there. We have built I would call it a two-tier setup, in the sense that on the local cluster, we basically monitor and log everything and store it locally, and then we cherry pick key metrics and key logs, use Prometheus remote writes to ship that to shore, and then have a Prometheus onshore as well to monitor the entire fleet and with these key metrics. But once something blows up, we go onto that specific vessel and have full observability available. Registry caching. Ooh, that's the hot potato. Imagine that you have 3 servers sitting on a vessel. You don't want to pull the same image 3 times. You want to pull it once and then share it across the 3. Cool. That's what Harbor can do. Let's go use Harbor. And we use Harbor, definitely. The problem with Harbor, or at least the problem with our Harbor approach, was that that's installed inside Kubernetes. So when Kubernetes is, sorry for my French, fucked up or in some kind of non-working state, then our Harbor is in an equally non-working state. And that's especially important when we talk about fetching containers in relation to Kubernetes base system itself and in relation to the OS. So that actually made us do I don't know if I should call it a patch, but at least a slight change of methodology during spring here, where we also started using Docker, where we have a local Docker registry on one of the nodes that is basically caching all requests from Docker I/O, and thereby we capture all the requests for Kubernetes components and all requests also for OS components. It's not a total fail-safe approach, because if that node goes down, then we have failover to another node, but they don't have shared storage. So that's a new node will still need to pull everything down, but that's only in the event of failure, right? So such a two-tiered approach or two parallel branches approach right now, I think we'll do something about this moving forward. I don't have clear visibility into what our kind of final solution will be, but it hurts my engineering heart that we have 2 things in parallel that are doing the same thing. Yes, Flux CD. That's the item used by our customers for deploying applications. They can happily live with a pull model. So we basically have a Flux CD running on each cluster, pulling applications directly from the customer repositories. Working like a charm, I must say. That was kind of the touch points that I would like to highlight, or the design choices that I would like to highlight. If I should speak a little bit about the SUSE experience, I have two slides. One is about SUSE Edge, or the SUSE software tool stack, and the other one is about SUSE consulting. SUSE Edge and SUSE tool stack. I think first and foremost, I am 95% advocate of the SUSE tool stack. I think it's a really cool tool stack that we have with SUSE Edge, and the end-to-end coverage of it that really impresses me, and the fact that we could build a proof of concept platform in basically a week and show to our, and feel confident to show to our customer that would not have been possible, at least not to my knowledge, with any other ecosystem. I also sincerely admire the high expertise we get when we reach out to support in SUSE, especially on the key components on Kubernetes and on Rancher. It's very clear that those are core offerings from SUSE, and we get very high quality support. We can see that when we face a problem, and from time to time we hit some stones that nobody have ever hit before, because we are in a niche, right? But we can see that they follow up, they actually push it back into GitHub, etc. So all good on that one. The other part of it, not so good stuff. I think I at least see two major points. Elemental Teal. I'm sorry to say, but come on, SUSE, get your act together on that one. We have spent tremendous amount of brain power and time understanding what is the thinking behind Elemental Teal, and how are we what is the mechanisms that we should use to customize the bare bone OS. That was completely impossible to understand in the autumn. The documentation has improved somewhat, but I must say that's our single major point of pain in this. And I have a feeling that this has not really been used on bare metal until we did it, because there were some findings about device recognition, etc. That was just so fundamental that I was at least surprised that it was a problem. So to speak. The fact that we had two physical hard disks in our servers was causing trouble for Elemental Teal. It sounds like I cannot get a straight answer right now when I talk to the roadmap guys, but as far as I understand, we are moving away from Elemental Teal and adopting a full Sleaze Micro instead. That's kind of the go-to approach, and I fully embrace that one, because Elemental Teal is simply like this knight that has his arms and legs cut off. I can still bleed on you. Yes, that's fine, but sometimes you need to do a little bit more than just nothing. Yes, the other item, and that's where we are a little bit on a niche, but either you have really good connectivity or you have total air gap, and we are sitting somewhere in between. We are not an air gapped application, but neither do we have a good fat pipe back to all the repositories. It especially Rancher is not really fond of that situation. Consulting. I think the good stuff, where we engaged with SUSE Consulting pretty early in this journey back in August last year. We had a thorough review of our solution, and that was really super fruitful and super professional in my book. It really made us feel much more comfortable giving full speed ahead on this solution. The not so good stuff, and that also ties back to elemental teal, I must confess on that. But there was a clear knowledge gap that, because when we were starting to face problems with elemental teal, our natural approach was, hey, consulting services, please bring in some of your knowledgeable guys and help us do this. But we spent a significant amount of time and money on getting nothing, honestly speaking. And that's not really satisfactory as far as I see it. I've been in a couple of calls where SUSE internally started discussing between consulting services and R&D. That's not really impressive, at least not in my book. But that being said, it's always easy to find the holes in the cheese, as we say in Danish, right? I don't want to leave an impression that I'm dissatisfied with SUSE, because I'm certainly not dissatisfied with SUSE, especially SUSE Edge as a tool stack. I can clearly recommend that one. Yes, there are some I don't want to call them minor, but there are some areas that are failing a little bit. But it's definitely possible to handle. So all in all, I'm all in, and I'm advocating for adopting the SUSE Edge tool stack. There should be no doubt about that. Yep. If I remember correctly, yes, that was the last slide.